All right, so way back in chapter 5, when we were talking about factoring, we encountered quadratic formulas for the first time. So in this first example, right at the top, we've got this equation, x squared minus 6x minus 55 equals 0. And so what I'd like you to do, I'm going to give you 2 minutes. This is just a review problem. I would like you to solve this problem right here by factoring, okay, and come up with the solutions by using factoring and the principle of zero products. All right, so here goes. This is just a refresher. Okay, so being able to factor, being able to solve something by factoring, this is hopefully one of the skills that you'll leave this class with, so that when you get to college algebra, you're able to do this nice and efficiently, because it's something we'll use a lot in that class, or whoever your instructor is. So x squared minus 6x minus 55, there is a 1 in front of the squared. So what I'm just going to do is unfoil this as we've done in the past. So my firsts, what are my only options for my firsts in this case? X times x, that's great. And then because my lasts multiply to give me a negative 55, what are the signs that I have to use? Yep, one of each, positive and negative, or a negative and a positive. The order does not matter. And then I'm going to pick the two factors of 55 that are 6 apart. And what are those two factors? Yep, they're going to use a positive 5 and a negative 11, and I put them in that order because they have to add up to the negative 6. So then that's the factoring part, and then we have these two numbers. I don't know either of these numbers, but I do know when I multiply them, I get 0. And so this was what was called the principle of zero products. It allowed us to just take each of these and say, okay, if I multiply them and get 0, then one of those numbers has to be 0. In which case, we either get the x value negative 5, because negative 5 would make the first parentheses 0, and I get 0 times whatever, so equal to 0. And then the second number, when I add 11, would be 11, which that makes the second parentheses 0. We always write our answers as a set. So these are just two answers. This is not an inequality. This is not an interval of answers. So I'm going to use some braces, and I'm going to say, okay, I'm going to list out my answers, negative 5 and 11. Please remember, I've tried to help instill in you an appreciation for good notation. If you wrote this down, if you used parentheses instead of braces, that's wrong. That's interval notation. You are communicating intentionally or unintentionally, you're communicating something completely different with this right here. So that would not be the way to express this answer, not with parentheses. All right. Well, then, just like our section that we had before the pause for Thanksgiving, there's only one thing in this section. Okay, and that one thing is to answer this question. Well, what happens if this doesn't factor? What if I had made this x squared minus 4x minus 55 and it no longer factors? Are there still solutions to this? And since these solutions, when we get to drawing pictures that represent this equation in college algebra, The solutions, they represent something. So it would be good for me if I could solve it. And the answer is yes, we can. What we're going to use is something called the quadratic formula. I'm not going to have time to show you where we get this, but this is the representation of the solution of any quadratic equation. So what this says is the following. If you have an equation that is in this format, ax squared, so the letter a is always in front of the x squared, plus bx, the letter b is in front of x, and then c is the number just added on there at the end. It's equal to 0. Then the solutions are given by this format. So your challenge that you have is you have to remember the quadratic formula. Okay, this thing right here. The solutions, the x's, are equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So if you don't already know this, if you've never seen this before, if this is not part of the information that you came in with, my encouragement would be start with the stuff under the square root. That's actually the most complicated part, the b squared minus 4ac, and then remember the rest from there. So here's what I'm going to do. My first example, I'm going to take the equation we just solved by factoring, and I'm going to use the quadratic formula just to show you we get the same thing. So help me here with my first step here. I've got to substitute. What is the value of a that I'm going to plug into the quadratic formula for this equation? 1. What's the value of b for this one? Okay. The negative counts, so not only the 6, but we're going to say the negative 6. Okay, but you're looking in the right place, so that's the good news. And then what's the value of c going to be? Negative 55. Once you identify that, and once you remember the quadratic formula, these problems are no more than just a plug and chug. Okay, so you just got to get used to remembering the quadratic formula. That comes from practice. I always encourage students, I don't know what works for you. Hopefully you know how your brain works. My brain, what I have to do when I need to memorize something is I got to write it on a 3x5 card. And I've got to just go over and over it and until I finally get it, and it takes a little time. So whatever works for you, make sure you do that. So now my solutions, my x's are going to be in this format, and I'm just using the quadratic formula. Negative b. Well, since b is negative 6, what's negative b going to be? Yes. Positive 6, exactly right. All this is telling you to do here in the quadratic formula is change the sign of whatever b is. Okay, so negative b just means change the sign. So that's going to be, in this case, positive 6 plus or minus. That means I'm going to have 2 answers. I'll explain that to you in just a minute. Underneath my square root, I've got b squared, which is negative 6 squared. What do I get when I square negative 6? Positive 36. Negative 6 times negative 6 is positive 36. Minus 4, that 4 is just part of the formula. The value of a, which is 1, and the value of c, which is negative 55. And all of that is over 2 times a, or 2 times 1. The rest of this is just some arithmetic. Got your calculator, or if you're just like, if you're good at arithmetic, that's great. But the rest of this is just simplifying this down a little more. So my solutions, my x's are 6 plus or minus. Whenever I'm evaluating this, I'm just trying to give you a little bit of hints and tips here. I always start with this multiplication. Okay, so I've got 36, and then when I multiply, I've got negative 55 times 1, that's negative 55. And then times negative 4. So I've got my negative 55. Whoops, I put that in the wrong way. Negative 55 times negative 4 is going to be positive 220. In the bottom, 2 times 1 is 2. 36 plus 220 is 256 over 2. I'm just going to take a shot with that 256. If it's a perfect square, great. If not, then I'll have to go ahead and simplify it, but let's see. So I've got the square root of 256. In this case, that works out to be 16, so that's good news. So here's what I've got. I've got 6 plus or minus 16 over 2. And here's what the plus or minus, that symbol right there, means in case you've never seen it. What it means is what you're going to do first is you're going to add the 2 numbers on the top, and that's going to give you one of your answers. And then you're going to go back and you're going to subtract the 2 numbers on the top. And that's going to give you your second answer. So the first one, 6 plus 16, that's 22 over 2. And then the second answer, 6 minus 16, is negative 10 over 2. And 22 over 2 is 11. Negative 10 over 2 is negative 5. And you see that I got the same 2 answers as I got when we factored it up at the top. So you're not going to end up with different answers if in the event. So if you don't like factoring, if that doesn't really appeal to you as far as solving these, you can use the quadratic formula for any and every equation that you're going to solve. So what I would like you to do, please, is take the same principle and go ahead and do exercise 1. Go ahead and solve that quadratic equation in exercise 1. Just to give everybody a nudge, make sure we're all moving the same direction. What's the value of A that you're plugging into the quadratic formula? 4. And then B is? Great, negative 11. And C is going to be perfect. Keep going. Now you're just plugging and chugging. So do the best you can. I'm going to get started on the arithmetic. Check your work with mine. If we differ at all, let's talk about it. I want to make sure that you're comfortable with the quadratic formula. But again, the only real new stuff here is using the quadratic formula. I know that you've done plenty of arithmetic Just got to get comfortable here. So when I go ahead, my solutions are going to be negative b. Remember, that just means change the sign on b. So that is going to be positive 11 plus or minus. That means there's going to be two answers. Then I've got my square root of b squared. Negative 11 squared, negative 11 times itself is 121. Minus 4 times a, which is 4, and c, which is negative 3. And all of that is over 2 times a, so 2 times 4. And put the appropriate numbers in the appropriate places. Now, process of doing some arithmetic, I'm going to multiply these three numbers together. So negative 3 times 4 is negative 12. And then negative 12 times negative 4 is plus 48. Underneath the radical, 121 plus 48 is 169. And again, I always take a shot and see what happens when I take the square root. Otherwise, I'll have to try to simplify that. So the square root of 169, that turns out to be 13. So that's great. I've got my square root all worked out. And then here are my two answers. I'm just going to separate them with arrows here. 11 plus 13, that's 24 over 8. 11 minus 13 is negative 2 over 8. And that gives me the following solution set. Negative 2 over 8 reduces to negative 1/4. And then 24 over 8 reduces to 3. And there's my two solutions to that quadratic equation. You understand that first exercise? There's nothing else tricky in this. We're just going to go ahead and practice. But if you have any question at all about that, please bring it up. I want you to do great on this next test. I want you to crush that when it's on the final exam, and have it not be any big deal. Before I go on, any question? All right, well, then the next one, I've got another example. I've kind of taken up a lot of room, so I'm going to give myself a fresh little piece of paper here just to have a little space. So on this one, I've got 4x squared equals 8x minus 1. Here's the reason I've given this problem. What do I need to do here before I can apply the quadratic formula? I got to put them on the same side. I've got to switch the signs, move them to one side so that it's equal to 0. Yes, indeed. That always has to be true. So what I need to do is I need to take the 8x and bring it over to this side. So I'm going to subtract it. And then the 1, I need to do the same thing. I need to bring the 1 over to this side. So I need to add the 1. So when I do that, what I now have is 4x squared minus 8x plus 1 equals 0. And I'm ready to rumble. I'm ready to go ahead and solve this using the quadratic formula. The value of a that we're going to use is 4. The value of b we're going to use is negative 8. And the value of c we're going to use is 1. So my solutions always follow this the same format. It's the same every time. Negative b, which means change the sign on b. So b becomes 8 plus or minus. B squared is negative 8 times negative 8. That's 64. Minus 4 times a, which is 4, and c, which is 1. And then all of that is over 2 times a, or 2 times 4. Put the appropriate number in the appropriate place. That's the challenge of this section. I try to approach every problem the same. I just always like to multiply those numbers together. So 1 times 4 is 4. 4 times negative 4 is negative 16. This time, underneath the square root, 64 minus 16 turns out to be 48. And that's not a perfect square, unfortunately. You put that into your calculator, you're going to get a decimal. So what I'm going to do here is I'm going to do my best to simplify that radical like we talked about before our Thanksgiving break. And then I'm going to see what happens here. So 48. This is a process hopefully you're familiar with. You did it a whole bunch of times. There's a lot of them on homework. I need my perfect square factor of 48, and that's going to be 16 times 3. The product rule of radicals says I can treat each of these numbers on their own. So the square root of 16 turns out to be 4. And then the square root of 3, I can't do anything with. It's just going to stay the square root of 3. And then last but not least, here is my final step. I'm going to reduce that fraction. Something I've told you before, but I know it's easy to forget this little detail. Division is distributive just like multiplication. So when I reduce, I have to be able to reduce from each term. So 8 and 4 and 8, I can reduce all of those by a factor of 4. 4 goes into 8 2 times. 4 goes into 4 once and just leaves square root of 3. And then 4 goes into 8 2 times. And there's my 2 solutions. I'm mathematically lazy, so when I go to write my solution set, I'm just going to leave it in that format, 2 plus or minus the square root of 3 over 2. Some students, they want to see both solutions. So if you want to pull those apart, so if you want to say, okay, I've got 2 plus the square root of 3 over 2, and then I've got 2 minus the square root of 3 over 2, that's perfectly wonderful too. Okay, it's not a required step. That's just whatever flavor you like better. All right, well, your turn. If you need me, raise your hand. I will come to you. I'll help you with any trouble you're having applying the quadratic formula. Happy to. Exercise 2, you've got to do the same thing. You got to get that equal to 0 first, and then you're going to solve that. All right, so the first thing that I did here is I added the 5x to both sides because we need to have it equal to 0. That is a non-negotiable. So whether you're going to solve by factoring if a problem factors, whether you're going to use the quadratic formula, first step has to be equal to 0, no matter what. So that's good. It's consistent. So now that I've done that, I notice that the value of A is 3, the value of B is 5, the value of C is 1. It's always good to note that. And now I will plug this into the quadratic formula. So the quadratic formula says negative b, so the opposite of whatever b is, that's negative 5 in this case, plus or minus, there's my two solutions. Now I've got a big square root, and under that square root I have b squared, so 5 times 5 is 25, minus 4 times a, which is 3, and c, which is 1. All of that over 2 times a, which is 2 times 3. So that's negative 5 plus or minus underneath the radical. 1 times 3 is 3. 3 times negative 4 is negative 12. 25 minus 12 is 13. So this first example, I kind of gave you a number that you can't do anything else with. Square root of 13 is just square root of 13. It doesn't have any perfect square factors. So if you got to this point, you're like, what in the world do I do now? You leave it. Nothing else. So here's my solution set. Negative 5 plus or minus, there's two solutions. Square root of 13 over 6. There we go. Done with that problem. So not all of the square roots will have to be simplified like we did on my problem, the pink problem. Sometimes they work out that you can't do anything to it, and so you have less arithmetic. You're done quicker. Exercise 3, right below it. Go ahead and do that one. It's 2x squared plus 19 is equal to 14x. It's the same sort of thing. You're going to bring that 14x over first, and then you're going to use the quadratic formula. All right, so I subtracted 14x from both sides. So I have 2x squared minus 14x plus 19 equals 0. That is my quadratic equation I'm going to solve, which gives me a value of a being 2, b is negative 14, c is 19. Just want to ask a question right here. Is anyone having trouble identifying the a, b, or c yet? We doing okay with that? Now we'll plug in. So negative b, the opposite of b is 14, plus or minus the square root of b squared. 14 times 14, well, I don't know off the top of my head. 14 times 14 is equal to 196, minus 4 times a, which is 2, and c, which is 19. All of that over 2a, which is 2 times 2. And now we'll just work out this arithmetic slowly but surely. We'll get to the finish line of this. So here, 19 times 2 is 38. 38 times negative 4 is negative 152. (196) minus 152 underneath the radical, that is 44. So again, we end up with a problem that I can't take the square root of 44 directly, so we're going to have to simplify that. What'd you come up with as the perfect square factor of 44? You gave me the final answer. That's perfect. It's 4 times 11. Yes. And then yes, the product rule of radicals says I can now take the square root of that 4, and it is 2 times the square root of 11. Last thing I'm going to do, and then we're done with this problem, is I'm going to reduce it. I can reduce each of those three numbers by the same amount. Okay, so don't forget to distribute. So 2 goes into 14 7 times. 2 goes into 2 once and just leaves the square root of 11. And then 2 goes into 4 twice. And there is my solution set. 7 plus or minus the square root of 11 divided by 2. The next one that I've labeled example 3, I'm just going to go ahead and let you get started on it. The reason I've labeled it an example is because you get a surprise when it comes to the answer. It links back to what we did last week. So if you get to that point and you've forgotten, because it's been a week, then we'll pick that up together. So example 3, go ahead and plug it into the quadratic formula. All right, well, let's see how you did on this problem. So A is 9, B is -6, C is 5. There was no moving anything around on this one. It's what you see is what you get. So here we go. X is equal to -b. The opposite of b is 6, plus or minus the square root of b squared. -6 times -6 is 36, minus 4 times a, which is 9, and c, which is 5. All that over 2a, so 2 times 9. So now we'll do that arithmetic. Probably you were somewhere in the middle of doing that. So 5 times 9 is 45. 45 times -4 is -180, I believe. All over 2 times 9, which is 18. And 36 minus 180 is -144. So for the first time on our little worksheet here, I've got a negative number under the radical. So this is just an opportunity to remind ourselves what that means. So when I simplify this, what is the square root of the negative? What did we learn last time that is represented by? Square root of -1 is what? All right, well, it's good that I asked the question. So if you need to go back and watch that video if you hadn't, or do the homework, the square root of -1, that's the imaginary unit. That's our good friend I that we talked about a week ago. Square root of 144, that's 12. So I've got 12I, and then all over 18. And here's how we'll end the problem. When you have an imaginary unit as your answer, okay, we're not going to leave this as one fraction. We're going to break this apart. We're going to break this apart into 6 over 18 plus or minus 12 over 18I. And I'm going to reduce those fractions, but I didn't want to do two things all at once since I was giving you instruction. When you have a complex number answer, you do break the fractions apart. Notice I did not do that on the purple problem right here because I didn't have an imaginary unit. We can just leave our real numbers all as one fraction. That's totally fine. I mean, you can break those apart if you really feel the need to, but it's not necessary. So here's my solution set. 6 over 18 reduces to 1 over 3. 12 over 18 reduces to 2 over 3I. So we've got those two complex numbers as the answer to that quadratic equation. Again, thinking forward, college algebra, that's going to mean something. When you have an imaginary number as your output here for this equation, that tells you something about the picture of the graph of this equation. It has meaning for us. So that'll be good news. And I'll teach you, or somebody will teach you all about that in the next class. We just got a couple more problems to do. Exercise 4 on the next page. Go ahead and give that one another try. All right, well, let's see how you're doing on this one. Then we just got two more. So any issues that you're ironing out, if you need me, raise your hand. I'll come, we can talk about it. So in exercise 4 here, the value of A is going to be 1. The value of B is going to be 4. And the value of C is going to be 13. So the nice thing about the quadratic formula is it never changes. Once it clicks in your brain and you remember it, it's there. So -4, that's my negative B. Plus or minus the square root of b squared. 4 times 4 is 16, minus 4 times a, which is 1, and c, which is 13. All over 2a, 2 times 1 is 2. Taking care of under that radical, using my calculator or whatever other resources. 13 times 1 is 13, and then 13 times -4 is -52. No. Yes, 52. Sorry, there we go. Losing my confidence today. And then 2 times 1 is 2 in the bottom. 16 minus 52 is going to be -36. Well, once again, that's why I gave this problem, just to reinforce what we did in the last problem. What's going to be the expression for the square root of -36? 6i, perfect. The square root of the 36 is 6. The square root of the -1 is the imaginary unit I. And now when I separate that and reduce my fractions, I've got -4 over 2, that's -2. And then 6 over 2 is 3i. So there's my two complex answers to that quadratic equation. All right, if you got a question, you got a comment, concern, let me know, please. Exercise 5, second to last problem. You've got a little bit of busy work to do, unfortunately. On the left side of this, we saw this when we factored. In fact, I think I had a problem very similar to this on the test. You need to multiply these two things together and then bring the 10x over, and then you'll be ready to solve. So you gotta make that look pretty before you can solve it. If you need help with anything, raise your hand. I will scoot right over to you, help you best I can. keep working. I'm just going to get started with this busy work, shuffling things around. So you can check what you got, and then I'm going to pause, give you a little bit more time to finish up this problem. Not trying to rush you, just want to get you to a good place here. So up here, my foiling first, x times x is x squared. My outers, x times 1 is 1x or x. My inners, 5 times x is 5x. My lasts, 5 times 1 is 5. I'm going to collect those like terms. X plus 5x is 6x. And now I'm going to subtract that 10x. And this will be now finally in the format where we can apply the quadratic formula. So I've got x squared, 6x minus 10x is negative 4x equals 0. So my value of A, your value of A, hopefully you've been plugging this in already. A is going to be 1, B is negative 4, and C is 5. So I'm going to give you a little bit more time in case you stumbled around on the arithmetic, which is easy to do. You can finish that up. All right, so here's my quadratic formula. Quadratic formula says the negative b, the opposite of b. So since b was negative 4, negative b is 4. Plus or minus my big square root. B squared is negative 4 times negative 4, that's 16. Minus the 4, which is part of the formula, times a, which is 1, c, which is 5. All of that over 2 times a, so 2 times 1. And so from here on out, it's just a little challenge of arithmetic. 5 times 1 is 5, times negative 4 is negative 20. So underneath the radical, I've got 16 minus 20. 16 minus 20 is negative 4. So yet again, for the third problem in the row, we have a imaginary unit, the square root of negative 4. Well, the square root of the 4 is 2, and then the square root of the negative is I. And now I'll reduce those fractions. 4 divided by 2, that is 2. And then 2 over 2 is 1i, or just I. And there's my 2 complex answers to that original quadratic equation. All right, last problem for the day. Exercise 6. Go ahead and solve that using the quadratic formula. We'll compare notes. And then if you have any questions, we'll take care of those. All right, so here we go. The value of A on this one is 2. The value of B is -7, and C is 2, and we are ready to roll. So my values, my solutions, my x's are going to be -b, which is going to be 7, plus or minus the square root of b squared. -7 times -7 is 49, minus 4 times a, which is 2, and then c, which is 2. All over 2a, so 2 times 2. 2 times 2 is 4. 4 times the -4 is -16. So underneath the radical, I've got 49 minus 16. And 49 minus 16, that turns out to be the square root of 33. Good news for this last problem, that square root 33 does not have a factor that's a perfect square. It's 11 times 3. Neither of those numbers help us at all. So that's it. We are done. There's nothing else to do except write that as a solution set.